or locally. All right. Okay. So we're gonna in this class we're gonna talk about functions in C++. Now, functions are very important. It is one of the basic units that you're gonna write your program in. It allows you to organize your anything that's a little sophisticated program. You're gonna have functions. Now, the very first function that you know in C++ program is the main function. The main function is the entry point to the program. That's defined by the language. So it allows you to manage, to basically manage your program. And they are sometimes called modules, but the module can also actually mean different things. Like you may have later on, I'm going to introduce classes. A class could be a module. A function, a class contains many functions. A function itself can be considered a small module. So conceptually, they all called modules of your program. And then there's a lot of functions that are predefined. They're predefined mostly in the standard library. And a function, now this is doing a comparison with algebra. So in algebra, you also have the concept of functions. And it has a name, it does some computation. So here's some example functions. So POW, right? These three are in the C math, or in the C language is a math H, but really if you're programming in C++, make sure the headers you use are not the C headers, although they work for backwards compatibility. For C++ programs, you should always use the proper headers. So for a math H, that is going to be C math. So you include that header instead. So these three functions are the power function, the square root function, and the floor function. Those are probably you're very familiar, you have used them. And so those functions are put into different libraries. They're organized into logical groups, right? You have many different headers. It's just another way to organize the functions in groups. Mathematical functions are in the CMath header, as I mentioned. Instead of math H, use CMath. And this include statement, you're already familiar with. I mean, with the includes, and you see includes in every C program, C++ program. So the include in every language, there's some way of importing other modules into the program you write. So, in some languages, it's called the import, right? You have seen import, and that's actually one of the common ones. By the way, import is coming to C++ in C++20. So right now we're still going with the hash symbol include, and that is the traditional C way, and it also has been the way for C++ as well. So this is one of the ways you include other modules. We're very familiar with this. So functions can return values, or you may not return values. If it does not return a value, those are the return type is called a void. That's called a void functions. It does some computation, but it does not return a value as part of the function. Well, it may not return value. Actually, you'll realize later on we're going to have an example. You can still quote unquote return values through the parameters. If your parameters are passed in as references, we're going to come to that concept in a bit. But the value returning functions are, you have parameters, but they also have a return value. So to use the functions, you have to actually know, right? So the basic components of a function, you have the name, you have the parameters, you have the types of the parameters, and type of the return value if it has one. And so the return value from a function call, you may use that for further calculation. Maybe it's using another function. You call a function A calls function B calls function C, right? You'll see that, a chain of function calls. So it's very common. And then, it could also use that result in an assignment, right? After you do some calculation, you invoke a function and you assign it to a variable. Or maybe you use the result directly as a parameter in another function call. So there's just different ways of using it. And that's kind of called as a part of an expression. And so you can use that expression in wherever the expression is allowed in the language. Structurally, a function has a heading. And this is an example of a heading. This tells you, this is just calculating the absolute value. You're passing a parameter, integer, and then it's going to return a value, which is also integer. So this is a value returning function. Now, of course, if you just only have a heading of a function, this function doesn't do anything. Now, this is actually the line you may use to declare the function. Now, remember there's a difference between declaration and definition. You can use this heading to declare a function, but then it does not get defined until you have a body. So the body is where the code lies, like your function's code. How do you compute? So that's where the body is. And the parameters also are called the formal parameters. Now, in this case, there's one formal parameter, or we just simply call parameters. And we have a parameter called number. So when you actually invoke in the function, like in this case is the power function. And we pass this power function takes two parameters. Remember, you have the base, you have the power, right? And so in this particular statement, and actually here in this textbook, it says extra parameter, which is fine, but a more common way of saying it, this is U and a V here, they are called arguments. So when you have a function definition or declaration, you have the parameters, but when you invoke it, those are usually what you're passing. It's called arguments. The arguments match the parameters, right? Okay. This is sort of a more formal syntax here. So you have function name, you have a return type, which may be a void type. If it's a void type, it does not return a value. If it's not void, it returns a value. Then you have the parameter list, comma separated parameter list. And that function type here is the data type or the return type. Return type is a more common way of saying it. The formal parameter list, right? So here's an example. Apps function has one parameter. You have a type, you have a name. So this is the body in between the curly braces. In some languages, the default formatting, you put this curly brace, the left curly brace at the end of the heading line, but in C++ and C, this is more common to have them at the separate lines. It's just different conventions in different languages. A function call, you just saw an example with the POW power function. You use the function name, and then you give it an actual parameter list or arguments. Now the arguments is actually an expression in itself. The comma is actually an operator in C++. But then in the case of a function parameter list or argument list, is not necessarily used the same way as a comma expression, but it just happens to be the same syntax. So now here you may have a function that doesn't really take any parameters. That's totally valid. So this is, when you invoke that function, you don't pass any arguments. It's empty. So when you write the main function, the entry to a program, you notice if you're not taking the arguments from the command line, when you invoke the program, and then you can simply omit the argument, the parameters for the main function, right? So you have noticed that you write integer int main parentheses, but then if you actually want to take the arguments for the command line when you invoke the program, then you pass in two parameters. One is the number of arguments, the other one is the array of strings, right? Whatever you pass in. It's actually we're gonna get to that in the lecture about arrays. Actually, that particular array there is a multi-dimensional array. Then in the function, so when the function actually returns a value, you need to use the return statement to return a value. If the function needs to return a value, you have to make sure that you always return a value in, whatever your logic. You cannot just have an if statement that sometimes you return, sometimes you don't. That's an error. So you always have to have a return. If you actually, the function has declared a return type. So that's the return statement, essentially return an expression. Now expression can be a lot of different expressions, right? It could be a function call, could be just a constant, it could be another variable, it could be mathematical, basically it could be a multiple variables with, the operators, or maybe it's comparison operator, a plus b or a less than b, and then in that case it would evaluate to a Boolean. So there's just, many different things you can do here. So after the return though, once the program executes this statement, the control goes back to the caller. So what's say here is, in fact, the function calls, as I said, like A can call B, call C, there's a whole chain of function calls. And actually every time you execute a function, it actually will put some of the context, like the parameters and the location of the function code, onto a stack. We typically colloquially call that the call stack. And we actually gonna learn that data structure a little bit later. Is the stack data structure. So that's used very commonly for actually the how the computer runs a program. Here's a more concrete example. Now here's a function of larger, comparing two values and determine which one is the larger value. And in the end of it, we're going to return the maximum value between these two parameters. So this is a value returning where we have a return statement. Now, any questions about this so far? Is, you have seen a lot of this so far. This just kind of gives you a little more, just more clear understanding and exactly what the syntax is. A little bit more on the theoretical side. No questions, right? It's pretty basic.
No question.
Okay, good. Now there's another concept of function prototype. So you'll notice there are many concepts. Everything has a name. That's how we communicate. We name things. It's nothing fancy, right? So don't think it's something very. Now, prototype is a name that's kind of overused. If you ever use JavaScript prototype, function prototype means a very different thing in JavaScript. But here, the function prototype is very simple. It's simply just a heading without a body. That line that we saw earlier, that function type, function name, parameter list, this line is called a function prototype. And you don't need to, here's the one little difference though. You actually don't need to specify the variable name in the parameter list. So here we actually have the name, X and Y. They are not needed. You can omit them. If you have them, fine. You don't have to have them. So as I said, let's say in your main function, you need to invoke a function A. This function A either is defined before the main function, like in the order of the program in the same file, or it can be defined later after the main function. But then if that's the case, the program does not know what A is unless you declare it. So you need to add a declaration before the main so that it will know how to invoke A. And that declaration, you're going to use the function prototype as declaration. So where you may or may not use the variable name in the parameters. So there's some example here. This. So yeah, actually, this is the thing that I explained before. I said for the value return, make sure you always return. You don't just return sometimes. This will not be. This is not correct here, because you always have to return. Since you declared a return type, then you always have to have a return. So if it matches this condition, you return something. Otherwise, you have to return something else. Otherwise, this is just a compilation error. And the other thing also, the return, as you notice so far, we can only return a single value. Now, it does not mean you can only return an integer. What happens if you want to return two integers? So you have options, right? You cannot just return integer one, x, integer y, for example, and this doesn't work. But then you can put them into a structure. We're going to introduce structure. You can put them into a class in an object, right? You have different ways of doing it. A very common way, if you don't define a structure, it's called a tuple. You can put them in a tuple. A tuple is like a temporary structure. You know, you don't even have a name for this type. It's just generic tuple. We're going to see an example of a tuples. So yeah, if you do this, you're not returning the 2 to 3 and x. It's, remember previously I said it's actually, this is a common expression. Common expression is going to evaluate from the left to the right, but they only return the value of your last, the last expression separated by comma. So in this case, it only returns x, right? So it's a little tricky, but there's not really a very good or valid reason to do this. It only confuses people. So when you actually write a program, don't really do this, right? You want to separate this out, whatever you're trying to do. I mean, obviously this 23 is not doing anything here. Like if you actually do some calculation, I mean, this is not doing anything because this is going to be discarded. You did some calculation, but it will never ever be used. So what's the point? So if you, even if you write this, it's like, okay, compiler does not complain, but it's obviously a mistake, right? So it doesn't do anything extra because you cannot. But then what you can do, if you do want to return these two values, make a tuple. That's one way to do it. We're gonna see tuple. Actually, this is probably a good time to look at this tuple thing. Let's switch to some program here. All right, and right here, tuple, make tuple. Okay, so let me make this a little bigger. Are you able to see? It's good. Big enough?
Yeah, it's all right.
Okay. So now tuple, it was introduced, I believe, in C++11 or I think it was introduced in C++11, the standard 11. And anyway, so here's like a simple examples. The header for tuple related functions and types is in this header tuple. So previously we say, oh, you can only return one value. What if you want to return two integers? What do you do here? So this is the way to do. So you just, this is one way to do it. I'm going to show you different ways. You can use this make tuple function, right? The make tuple function, then you put, actually you can put as many values as you want, not just two. It will take as many as you want. So here we're going to take x and then another number 7, and then you return that tuple. Now this thing, we're going to talk a little bit more about this. This is a type specifier for a template, and one of the later classes we're gonna talk about templates. But very simple right now, just to know that this tuple allows you to put arbitrary values, arbitrary types, any types you want. You may have a double, you have integer, have a string, whatever you want to put in here, another object, right? It will take all of it. And in this case, it just so happens that we have an integer and integer. So we have the types of the elements in here as part of the template argument, right? So this angle brackets, it specifies the types of this structure that's needed. Now this is going to type parameters, and we're going to look into more details here later. Right now, just kind of, that's the level enough for you to get going. Just this is okay. So hope this doesn't bother you. Just get used to this. The standard C++ library has pretty much almost everything is templates. So we're really gonna talk a lot more detail about the templates. Okay. Then here's some little more example. Let's say I have an integer n equal to 1. And same thing like before, I can make a tuple. As I said, it can be, whatever objects you want to put in. 10 is an integer, a string, and a double. And then here, this is a reference, right? And don't worry about this too much now, but it's just another function call. And then you have another variable, which is an integer. And then the return type, as you notice, hover over this, right? My IDE shows me a lot of stuff. In fact, it does not even tell us, like, it does not even list out all the types in the angle brackets, because the compiler is going to be able to defer remember that previously we have an integer as the type arguments, but here we have so many different things, right? All these things that are passed in, they're going to be basically effectively all in there. Right here now it's just omitted. It's a ellipsis, just a dot. And by the way, dot is a valid operator in C++. It's when you have the unknown number of arguments, that's what you do. So it does not even show, because if you really want to type that out, if I want to type out that type, like tuple, right, and then specify everything, and then you can. That's just tedious, right? So instead, use this auto keyword here. It will deduct. The compiler is going to figure out what the type is. You don't have to write over here, which is fine. And and here, this is how you get the elements. Okay, so okay, now I know how to make a tuple. I put all the values in here. I pass this around. How do I access the elements? This is how you access them. It looks a little strange. You put the numbers in the angle brackets. Now this is also just like an array. It's a 0 base indexed, all right? So the 0th is the first element, and 2 is the third element. So if you run this, this is under chapter 6, picture, make tuple. All right, we're just gonna focus on the previous one here. So see, the value of t is, we'll basically print out the the tuple that we just made. See that? So this is how you access the elements. And then there is also different ways to figure out, once you have made a tuple, you pass it around, and then you can access it through this way, through the index in this angle brackets, right? But then you also have a different way to do it. So here, let's say f, remember this f returns this tuple of 2 integers. And here, what you do is you need to decompose that, so you can, basically destruct the value of a tuple into multiple variables. And then you can use them without accessing with the index, okay? So this is how you can do it. It's just another way. You can use this a tie function. and tie, and they specify two variables, and those variables will be assigned values of this integer tuple. So essentially, you see A and B will be assigned, we'll call the function f, and becomes 5 and 7. So A is going to get a value of 5, B is going to get a value of 7. Any questions so far about the tuple? Like just, how to make a tuple, how to access the elements of the tuple. It comes very handy. You're
No.
gonna use this a lot. Okay.
Y is equal
There's
a function. I just have the question. It says tie AB equal F. That is function, right?
yeah, it is a function. Now, you might have noticed something really strange. Like, okay, this function is on the left-hand side of the assignment, right?
Yes.
Which is so. There's some little advanced concepts going on, but it's just not the, it's not necessarily the right place to explain everything. Just know how to use this. You can just follow this pattern. This is one way to do it. But there's a lot of detail goes behind how these things work. A little more on the theoretical side. But just know that this is one way to do it, okay? So when you, instead of doing this way, this is just another way. If you break that tuple down into individual variables. This is just one way to do it. There's another way to do it. This is probably, I would say, more preferred. You use this auto type. Auto just means that I don't want to specify the type of the variables. Just let it be auto, deduced by the compiler. So, and here, this square bracket is another way to unpack the tuple. In this case, we're unpacking two integers. So you'll notice here, we're unpacking, 5 and 7 into A1 and B1. And this particular syntax is, newer in the version 17, okay? But it doesn't really matter what version it comes from. Just know that this is a standard C++. Just, totally okay to use it. In fact, they're preferred, all right? And then, I guess I'm gonna leave this for later. So this is talking about references. Hope that's, this is the, I think it's basically you wanna know at least this much about tuples. I want you guys to be able to use tuples and then use this in your assignment. It comes very handy. Now, I know the textbook has introduced a different way of returning values through parameters, and you can do that, but I think that is more of sort of a C style programming. You want to use the function return as the way to return, and not through your parameters using references. And we're going to talk about references just in a bit. All right, let's go back to the slides. Okay. Now this is still talking about if you actually you need to return, the function has declared, I need to return a char, okay, a character. And then you want to make sure you're going to return in every case. Now you might have noticed this is missing a default case. So it needs to actually have a default case. That also you return something. Right? So there's a bunch of examples of listed here, and you may follow along and look at the textbook if you want to read more. So we're going to skip them right now. We're going to show some other things instead. And we already talked about the main. That's the entry point to the program. Every language, there's some kind of entry point that's already defined. Sometimes they call it main, sometimes not called a main, but main is very common. It's called a main in Go. It's called a main in Java. Pretty much they are kind of influenced by C++. So here we'll talk about, declaration and versus definition. If your main is to invoke a function that's not defined yet, program has not seen it, but you need to declare it. Using the prototype of the function. Otherwise, the compiler is going to show you an error. It's not going to compile. So a function call, the so-called the transfer of control. Now, this has to do with just kind of remember that your operating system, when it executes your program, it just follow the instructions of your program, and it goes traverse your follows your line of statements one by one, and then when you do a function call, then you put the context into a stack, and you invoke that function. One is the return. The control goes back to your main program, and so in some applications, it never really exits. Like always, the main program runs forever, like a web server, for example. And so, but then for our simple examples here, they usually terminate after a few seconds. Whatever computation you do is very short. That's not always the case. You may have a program that's just continuously looping. So that's the thing about the control flow of your program, how the program runs with the function calls. Then the void functions, they're basically simply saying we're not returning a value with a return statement. But it does not mean you actually cannot put a value back. As I said, alternatively, you can still pass value back to the caller by using the parameters. But if your parameters are passed as references, we're going to talk about references. And so here we basically say, it doesn't matter return type. You're not going to have a return statement in the function. Well, no, sorry, I can take it back. You can have a return statement, but then you return no value. Just simply a return semicolon. That's the statement you have if you need to return early. Now, if you don't need to return early, then you don't have to write a return statement in the very end that returns nothing. Let's say you are looping through something, and then when you encounter a condition, you want to just break out of the loop, actually return it right away prematurely. You have other code that's not executed, and then you write a return statement. That's one way of using it. And then otherwise, you want to run the code through your function body, and then you don't need to have a return statement. So we first talk about your function may not have any parameters. You may not take anything that's optional. Yeah, parameters are optional, and the call to the void function is a standalone statement. Well, it's called standalone because it does not return a value. You cannot really combine this with, you don't really assign this value to something else, or you don't really do another function call with this void function when you call that, because it doesn't return any value. So it will be replaced with nothing after that function returns. So that's kind of what it means by standalone statement, typically how you use the void function. And we'll look at some examples. This is not so much different than before. Now, here, introduced a new thing here with an ampersand. Now, the ampersand is it's called address-f operator. So if you have a function that actually takes, this is called a reference parameters. And then when you actually invoke it with an argument where you pass a variable, and then what's actually being passed to the function, what happens in the program is that the address of that variable, wherever that is located in the memory, the address is passed into the function call. But in your function body, you still use the variable as if it's actual value because it's sort of dereferenced automatically. That's just, how the language works. There's similarity between references and pointers. And I think we're going to talk about that maybe a little bit later. It's not in this class, but you have seen those things, but we're going to get to talk about those things in a little more detail. Just right now, you need to understand this at this level. And this is all the same thing as before. When we have a value return in, this is the void functions. not a huge differences. Now, this is the place where we talk about reference parameter, not necessarily only the void functions that will take the reference parameter. Is not so at all. Whether the function returns a value or not has nothing to do with what kind of parameters you take. So again, there's two ways of passing parameters or arguments to a function. You can pass by value, you can pass by reference. When you pass by value, the function actually receives a copy of the content of the arguments when you actually invoke the function. It makes a copy. For performance reasons, or for if you have a performance critical code, you probably want to avoid copy as much as you can. So and that's where the reference comes in. When you use a reference parameter, the variable that you pass in as the argument for the function is not copied. Essentially, it will actually just give the function a address, almost like a pointer. And in fact, the references are implemented with the pointers, but they're not the same thing. So, and then in that case, we don't really make a copy of that argument, right? The function essentially receives the location, and then in the function body, that, the content of that parameter is accessed by dereferencing the location, and then it will retrieve that content, but there's no other copy of the content. Now, it might be a good time to look at another example here. Let's see, do I have an example? Okay, just look at this as an example, right? This get number function, it's taking, now this is returns a void. And by the way, this is actually the prototypes. Remember, we talked about prototypes because the main function, these functions are defined after the main function. The main function does not know them unless you declare them. So that you have to do this. This is defined later on, but you have to declare this function here through the prototype. And this is where it takes. Now, if you remove this, remember this parameter name is optional. You can actually do this. But then sometimes it's good to leave it there just for readability. People see that, it means something, right? What kind of parameter it takes. That usually is a good idea for documentation purposes. Not that a compiler needs it. Compiler does not need it. It only needs this to find out the matching function definition later on. That's what the compiler needs. But as a programmer, we will probably want to have documentation. So this is an example of reference passing. Since it's a pass reference, and in fact, you see this one does not return a value. Instead, in the function, it's expected that it's going to change the value of the number that's basically, because here we're passing by reference, so we're changing the memory location of that parameter that's passed in when we invoke it. So that's how we achieve sort of a quasi return, right? But we're modifying a variable. It has so-called side effects. In some language, you'll call side effects. Now, functions have side effects, not necessarily a good practice in many languages, but in C, C++, it's actually okay. It's totally okay, but then, it depends on personal style, but then I personally don't use it that way. But there are cases where you may want to use it that way because it's just more natural. But here, if you really want to return a value, then you could essentially return an integer, something like that, and then so that you don't really modify something that's passed in. Because once you do that, then that variable, the caller of the function needs to know that this value has been modified and needs to know that the original is gone. So that may or may not be what you wanted. It depends on the situation, okay? So just a little example there, okay? Okay, let's go back here. Now, question about that so far? Passing by reference.
No, I'm good, Professor.
Okay, good. So just a little more, the formal parameter, if it's a reference parameter, it receives the memory address that I just explained. The changes to the formal parameter will change the corresponding actual parameter or the argument. That's the side effect. So it mentioned, it may be useful in these situations if you want to change the actual parameter or the argument in the invocation of the function. You want to return more than one value. Now, as I mentioned, there's an alternative there. You can use tuples, or if you have structures or objects. And of course, if you're passing by the address only, you may save memory space or may save time because you no longer make a copy of the value. So when a function is called, so this is talking about, so it's important to understand actually, how does C++ program manage its memory space? There's actually 3 memory zones in a C++ program. You have the stack memory, you have a sort of heap memory, then you also have so-called static storage area. So there's, we're going to talk about static in a bit. And when you do a function call, inside the function call, the formal parameters and the local variables are allocated on the stack. So here it says the function data area. This is actually more commonly known as the stack. It's basically, then we'll call it the call stack, okay? Now, what's good about these variables is this, and the parameters also, and local variables. The deallocation of that memory is managed automatically for you. So previously remember that, okay, if you have a, like, remember when we don't really use a delete operator on something that's not created with a new operator. The reason for that is the new operator actually allocates space on the heap, not on the stack, for that variable. And so when your function returns, that memory location is not released unless you release it with a delete. And if you just declare, say, integer a equal to 1 in the function, that is automatically managed. It will be allocated, deallocated automatically by the program. And that is actually also important to understand is that can you actually return a reference to a local variable? What do you think? Anyone? Let's say you declare, okay, let me give you an example.
Yeah, an example, please.
This x equal to 5. And let's say, well, actually, let me write something. Let's say I have a function, integer. Let's say it's called a g function. I have integer x equal to 5. Now, remember, we can take reference parameters, right? What about reference return? That takes the address of something. And it can actually return, the address of x. Well, I mean, the ID already shows you it can't. Why? Do you understand why, though? I just kind of explained that concept, and maybe you can figure out why. Because the memory space for x is a local variable that is managed automatically. Upon the return of the function, this memory space will no longer be valid. is deallocated. So if you return a reference, that's a reference to nowhere. That memory location is no longer valid. So that's why you cannot return a reference to a local variable. Now, what you can do though, as later we're going to figure out, you might say this is a static. Remember I said there's, hold on a second. It might be non-const. Make tuple. So we're actually going to look at this a little bit. Actually, this is, I need to figure out what is here. Talking about the non-constant must be a L value, initial value of reference to non-constant must be a L value. And this is actually another way to do this, but we're going to look at the example. Let's skip this for now. We're going to look at this in another example. And this is not a very good example here. So the actual memory's address, this is talking about reference parameter again. You pass the actual parameter's address into the formal parameter when you do the invocation. So when you change the formal parameter value, it will change the actual parameter value too. This is what we're talking about here. It's not recommended because the memory space for that local variable or the parameter variable is no longer retained. It will be deallocated at the end of it. It becomes invalid. Now, we're going to talk about the scope of identifier because the scope is that actually when I say this variable X, it goes, like it's going to get deallocated because that's kind of go out of scope. And then what does scope mean? Scope means if in a program whether the identifier is accessible. And in C++ it's called, we call it block scope. A function defines a block, and within that function body, I mean, typically when you see the curly braces, this is kind of how you know this defines a block. And if you have a function that has a block, and this is a kind of saying this is has a scope. Now, any identifier defined inside is a local, well, if it's a local identifier, well, that's the scope, whether it can be accessed. This will be, it's limited to that block. You cannot just invoke that X outside. And then you may have a global identifier that's defined outside every function. And actually I have the scope thing here. This is a kind of more example here. So if you declare a variable here, like this way, is a global variable. Now, this is no longer recommended way of doing things. You're polluting so-called the global scope. You want to use, you want to put that in a namespace at least. Don't just declare something in the global space. Now, you may, let's say maybe you have a library that you're including, importing. Those has the same value, then you are overriding or shadowing that variable that's defined there. Now, it doesn't really happen that much anymore. Like you see, it's kind of a situation there, but in C++, pretty much the library that you use, you're gonna have, probably there are gonna be, there's a very few global things that's actually not even scoped. So usually the library you use, they're gonna have a scope, like you see a lot of this STD, that's a namespace. We're also going to talk about namespace a little bit, but the namespace is nothing about it, just kind of another block scope that all the identifiers are defined within. You have to access it with this scope operator. This colon is this called scope operator. It's a way to name things, and then a way to organize your identifiers, your variables, your functions, your classes, whatever, inside that scope. So you'll notice that everything in the standard library, not everything, I would say most of those things are under the STD scope, right? Namespace is a scoping mechanism. So we cannot have nested functions. That's true. You cannot have nested functions, not like a JavaScript, for example. But then what you can do though, is to use Lambda. Now we're going to talk a bit about Lambda a little later, because that is a feature that it's very useful in many situations. And a Lambda is not a function exactly. is not a class exactly, but it's almost like the equivalent of function. Think about like you can pass that around, or you can define a very mini kind of function. You can think of that way, but they're not the same thing. We're going to look at the example just in a bit. And the global identifiers are accessible. You know, like this global variable var1, you can access it in just any function here that if it's defined after that global variable, because now it's aware of it. And so here, you're gonna say, oh, okay, I want to access the var1. Now here's the problem though. This var1 global variable is overshadowed. It's hidden by your local parameter. This parameter is called a var1 too. How? Now the compiler is going to look at this and this is actually not the global variable here. And as we'll see, this is actually going to be the local parameter. If you want to access, I want the global variable that has the same name, and you're going to use that scope operator, right? So this is going to give you don't have a name because this is really in the unnamed namespace. Think of this global namespace where you don't have a namespace declared. That's why you don't really have a name here, but you just use, colon, var1. This will give you the global variable, but this one just by itself is going to get your local one. And you can also use the variables that are defined elsewhere. And in this case, as an example, you use this extern keyword to access a variable that's defined elsewhere. Now, elsewhere could mean in a different file. If I import this, okay, or maybe it's defined after, like for example, it's defined right here. You see the var2? This is where it's defined. But then we need to declare it here so that this function here is aware of a var2. So this is another way to do it, but then you don't see this very often. Usually it's more used when this comes from elsewhere. And you can use it that way too. Now, this is not a very common way of using it, but sometimes it's useful, but you're probably not gonna see this a lot. Just be aware of this. And there is another thing called, when we say the variable, the identifiers have a sort of scope based on a block. And this, just use the curly braces, introduces another block. So in here, I may also have another thing called a var1. Now this parameter is var1. I have another thing called var1 in this separate scope. Is nested block inside this function. So in this case, this is going to take reference. It essentially overrides that local parameter. So if you want to just use a var1 here, it's going to be recognized as this local variable in this block. And that one actually is no longer accessible. There's no mechanism to access that local parameter. It's just hidden. But you can still access the global one with this scope operator in here, in this block. So this just shows you, that's actually run this scope. So you see this here, var1, parameter 2. This is actually the parameter that we'll pass in. We'll pass in 2. The parameter, the argument is 2. So this is actually 2, not the global. This is the global. So 1. And in the block is 3. That's the local identifier. Any question about this? The scope?
No, professor.
All right, let's see if there's anything in the chat. Oh, yes. Oh, Ricardo, you're right. You're looking at the other ones? Yeah, I was looking at the, yes, you return this is a pointer, but then the, you're talking about this one? Yeah, is that right, Ricardo? Yeah, you're right.
That's what I
Now,
thought. That's
you're right,
exactly
you're
what I
right. But
thought.
there is a, I wanted to return a reference. I think in this case, you have to use, I believe you have to make a reference this way. I don't know if this is gonna work. So I don't want to get too complicated here. I just kind of wanted to actually, I wanted to say mainly for the, you know, this X will be deallocated if you don't, if you don't make this into a static. I think we're going to talk about static in a moment. Like this is, like this would be a not a valid thing to return an X. The point I wanted to make. If you just want to return the reference here. So actually, this is about the proper way to do it. But I don't want to talk too much about references because it's very complicated. We're going to talk about, you know, L value, R values, and PR value, those things. Those are kind of value categories. And that we can, you know, take another hour to talk about that thing, just about that by itself. But then just know that this is not common normally. You don't return the reference. Okay, it's good thing that you point out. But this I'm just I was writing a embedded function here. Make sense? Okay, we'll talk about the nested block, talk about the scope. Now these functions, as you see, they're defined and just like the variables that we define. In this particular case, it is global, it's in the global space. So it follows the same thing as the variable that we just saw. So the scope operator, scope resolution operator, the colon, we've seen this, how this works. And then extern, this is saying the variable defined elsewhere. We've seen the usage of this. Not very common, but once in a while you need to use it. Now, global variables is talking about, you don't want to pollute the global space. The recommended way is you make your own namespace. Simply just declare namespace like this, namespace, you know, my space, whatever, right? And then you can do something like this. And then you put your stuff inside of it. There's nothing to it. Namespace is just that simple, right? And then when you need to access this function f, and then what you do is you just use that namespace with a colon, just like what you saw with the standard namespace. Same, just there's nothing to it. It's just like this. Okay. So, but we're not talking too much about namespace here, but just talking about what's not good, what's not good, what might work. I mean, it works because C++ is, you know, the C is not exactly a subset of a C++, but majority of a C feature is available in C++. So it's kind of historical reasons. It doesn't mean that is the best way to do things in C++. So if you're writing C++ program, make sure you're writing the proper C++, not to hang on to the C stuff, although it works. Now, static automatic variable, we'll actually just talk about this, and then this is just a regular. So the automatic variable that allocated at the block entry and deallocated at block exit, essentially they're allocated on stack. The static variable they're put into, I said there's a 3 regional memory that are used in the C++ program. You have a static storage space. I mean, they're all memory, but then there's a static space where it's gonna store, the static variables are gonna be put in there in that particular dedicated space. And if you use the new operator, they are allocated on the heap, and essentially just any free place in your memory that may be used by that program. They are not necessarily contiguous. They are anywhere in your memory. That's that. But you need to manage your heap yourself. Stack is managed automatically. So is the static space. So the global variables are, basically are static variables as well, and they'll be put into the static space. Now, if you're actually inside a block, like in a function or in a curly braces block, then you got to use the static variable, static keyword here to declare that variable as static. So if your function returns that variable, that static variable that's declared inside, is not going to be deallocated. It will not, still lives on. That's kind of what it means for that. There may be use case for this, and then there's actually some examples in the book. Any questions about this so far?
No.
Okay. Now, this static is talking about the duration of the variable, like the lifetime, when it's deallocated. But it doesn't say where you can access that, right? So it's different concept than the scope, right? And even though your variable is still valid, but then you may only be able to access that variable, that static variable inside your function if it's declared in the function, and that's where you can only access it. Or the nested scopes, nested blocks inside a function, that's where you can access it. You have to follow that scope rules. And this is sort of orthogonal concern to what the static keyword trying to indicate how long this variable lives. Does it only live in terms of a regular local variable where you don't have a static keyword here? It only lives for that one function call, and it will be deallocated at the end of it. But then if it's a static, it will live on. Whatever value that after this calculation, this one function call, if you have a for loop, that value stays there. It will not be deallocated. Next time you invoke it again, that value stays whatever that was from the previous invocation in that for loop, if you're calling this one function repeatedly. Okay. Again, now this works. This is a kind of C feature, and there's alternatives to how you do this, not necessarily the best way to do it, but just know that it exists. In fact, sometimes you probably want to, in terms of best practice, you want to avoid it. Now, the function overloading. So what function overloading is really simple, right? It sounds like a fancy word. It really just means that you can use the same function name. You declare, because the function takes a different parameters. You want to be able to calculate the same thing depending on what's provided to it as arguments. So you can have many different flavors or variants of the same function that does the same thing. So those variants are so-called function overloading. But then you gotta have something that's different so that compiler knows which function you're calling. So the difference reflects in the number of parameters, or if they're the same parameters but they have different types. That you may have, let's say, a power function that takes integers. It may also take doubles, take floats, right? That's, you can see those things. Now in C, you cannot really overload them. This is the C++ stuff. So you can have many different flavors of them. Then you can, basically, because that's necessary sometimes. And in fact, if you actually have different types, in C++, a better way to handle different types is to use the templates. We have seen this in the tuple. How you make a tuple, you use the angle brackets, and then the type is abstracted out into an argument to the whole structure or function definition. You have a function templates or class templates. We're going to introduce those a little bit later, but right now just know that they exist. And yeah, so if the two functions are said to have a different parameter list, if they have a different number of parameters, or they have some kind of data type that's different, then there's another concept that when it comes to function, we know what's a prototype, what's a heading, and here there's a signature. Now the signature is essentially the part that does not include a return type. Like the whole prototype remove that return type, that's the signature. And that the signature is actually used by the compiler to figure out which function you're calling if you have multiple functions with the same name that overloaded. So that's kind of the purpose of that. Now that also tells you though, you cannot have two functions that only differs in the return type. You know, you have power function that takes integer and integer that returns, let's say, an integer. And then you have another power function, integer parameters, but then returns a double. It does not work. You cannot overload this way. You cannot just have a difference in the return type. So when it comes to the difference, we should only consider the signature, which does not include the return type. That signature needs to be different. Otherwise, the compiler will give you an error. It's just the way it's C++ rules, right? And now default parameters. Now, any questions about overloading?
Not right now, Professor. Not right now.
Okay. All right. Cool. Now, default parameters. So the default parameters is in the case where it kind of makes sense to provide a default value if you don't want to provide it. We're going to actually just see an example here. So let's say I have a sum function here. It takes 4 parameters. I have a default value for the last 2. So essentially, when you invoke this function, you have to provide arguments for the parameters that do not have default values, like x and y. And then you can omit the last 2 because they have default values. So essentially, if they have default values, when you invoke the function, you provide those 2, the default values will be used. Or you can just provide x, y, z. You have a value for z that's different from default, and then the w will be using the default. And or you provide all 4 of them, then you have your own values. Defaults are not used. So this gives you flexibility. So instead of writing an overloaded function like this, so essentially they say, I'm gonna have overload in x and y. Maybe I have, int x, int y, and z. Instead of doing this is gonna save you a lot of overload and say, I'm gonna just provide default values. It may make sense sometimes, not all the times. So as you see here, this is how you invoke it. You may provide 2, 3, or 4. And the value will be calculated accordingly. Oops. Right, so you see the first invocation, the sum, 25, because the last 2 are 0. And then if you provide 3, is the sum of those 3. You provide a 4, is the sum of 4. That just shows you what, default. Very simple. Oh, there's one rule. You may have noticed that default parameters we can only specify from the rightmost parameters. So you cannot just have a default parameter here and then you skip another one that's not a default and then you have another default. This does not work, not valid. Because the way you invoke it is like this, that's just one of the rules. You can only omit the parameters that's on the right, but not on the left. So that's a rule. All right, so that is that. Now I want to go through a few other things. Those are slides. The static. So that's the that's the static that we mentioned before. We have a for loop. You invoke that value of that count as a static variable here inside this function. Is remembered. It will not be deallocated at the end of this function call because the duration of that variable is in the static storage space. It stays on. So if you calculate this, like next time it calls, the second time it calls demo, the value will not be set to 0 again. This is only at the initialization. Once it's declared and initialized with a 0, and it will be carried on with whatever value that exists in the previous function calls. So if you run this, as you notice that it's printing out the values that basically comes from 0 initially when you initialize it. And next time you invoke it, this value is 1. Another time, because we are incrementing by 1, and then it's going to be 2, 3, or 4 in this for loop. It may look a little strange, but that's how this works. Any question about the static variable?
No, Professor.
Okay, cool. Now, there's one more thing I wanted to show, but it's not necessarily, let me see. Why did I have this in this part? Well, okay, I guess it's just kind of a, think of this as a little extra content. Now, normally our programs so far we have seen is just, it runs in this so-called the main thread. There's only a single thread. Now, threading is a way of using your CPU more efficiently. It allows you to parallelize the work, so to speak. And it's not the same as running multiple processes. When you load the program, run the program that after it's compiled or built, and you run an executable, the operating system launches a process. Inside that process, for example, this program called static, it runs normally. If you don't use threading, multi-threading is a single thread. It's called a main thread. And then you can use multiple threads. Now this is going to be useful in a situation where, let's say you have a web server and you have many users making requests to your server. And this is a program that actually, let's say, is a server. It runs in a loop, waiting for requests. And so every time a request comes in, and you launch a thread to handle that request. So by doing this, you can handle, thousands, tens of thousands of requests at the same time. If you don't use multiple threads, and then the user one's request will be processed by the main thread, and then user two's request will have to wait until user one's request is finished. So it does not allow much of a parallelism. It's not very efficient. So just another style of programming that, actually many of the programs you use today, even though you don't know what's behind it, but a lot of times it has multiple threads. Even this IDE, it probably uses multiple threads behind the scenes. Otherwise, it cannot do all these things at the same time. While I'm typing, how come it shows me this? Or sometimes it shows me an error, and actually multiple threads running in the back behind the scenes. Now, this is not something you're gonna do an assignment on or anything. Just gonna show you, just so you know, for completeness, that there's a threading here, and this is threading utilities is in here, and there's nothing but just objects, classes, create a new thread. Now this thread is implemented differently in the Linux system versus a Windows system that have native supports. Windows has its own Windows threads, and in Linux or Mac is perhaps using the P threads or the POSIX threads. There's just different ways of that underlying that standard. This is a standard library. It may be implemented different ways. So anyway, I'm not going to show too much detail here. Now just take a peek at this lambda expression. We're going to see this. And this is a very basic lambda expression. And lambda expression, I think, is a new feature in C++ version It was introduced to version 11, I believe. It's not that new, but hold on a second. Are you still able to hear me? It's
Yes, we can hear you, Professor.
yeah, okay. I thought my battery is out on my headset. Let me have to charge that a little bit. Now, this lambda expression, it kind of looks a little strange, but this is kind of the expression here. There's different flavors, but you have a square bracket. Then this is your parameters. Think of it like a function. This is like anonymous. It does not have a name, but you can declare your parameter list here. And then you have curly braces like a function body. And then you have your statements inside. And this may or may not return value. Okay, if it returns a value, let's say it returns 1, just as an example. Now we're gonna, I guess we're gonna probably do a little exercise a little bit later. So this, if I actually return a value, then you use this arrow symbol, say specify, I'm returning an integer here as an example. As you'll see, there's a lot of similarity with the function. It's not exactly like a function, but it's almost like a substitute for function because you cannot declare nested functions, but what you can do is you can declare lambda expressions or lambdas inside your function, and that will do some calculation inside. You don't have to have a whole function declaration, definition stuff. So this is a succinct, a short way of declaring something that's usually lambdas. You want to make it for small computation. You don't have a ton of statements inside. You might as well put that in a function. It's usually for small tasks. And then defining a function kind of overkill. So you may do things like that. And then obviously, this expression is, essentially that object. It behaves just like almost like a function pointers. The functions, that function object, like for example, even this operator parentheses, that's actually a function. That's the name of it, or this foo, and that can be passed around as a function pointer. Now that's more of a C style thing, but obviously it works in C++. And the function passed is basically you're passing your behavior, not just the data. Usually you've seen, the functions you so far will passing data around. But what if you want to pass the logic of calculating something around? Then you pass a function using function pointers, or you may pass lambdas around, right? So those have sort of the behavior encapsulated, and that allows you to do something really interesting. Even in some of your assignments, you probably want to consider usage of lambdas. Now, I think I have more examples of lambdas, and let me see. Okay, so here, take a look at this programming example. This is in the book. Now, you have this example of calculating the larger value. It's a very basic example. Now here, this is a declaration, and the function is defined after the main function right here. And it's a very simple basic function, as you see, right? And just comparing the value of x, y, and determine which one is larger. And here you have a for loop. You're basically taking inputs from your command line, and then try to print out the largest one. You basically try to figure out which one is the maximum. You're gonna give, let's say, 10 numbers, and find out which one is the bigger ones, the biggest one. So if you run this program, right? So let's say it's got a largest number. All right, so if you run this, okay, let's say you give 10 numbers. Do I have 10 numbers? Let's just say 200, 5, 11, 12, 50. Okay, that's 10 numbers. So obviously we'll find that, okay, the maximum is 200, right? And you know, just do this for loop and then comparing the number and then remember the current maximum number and then keep comparing that with the new number that comes in. So that is all fine. And now the example I want to show here is there's another way to write this. Here, use the function, right? It's a little piece of code, a very tiny piece of code. So a better way, just more natural way, is to use lambda. As I show an example here, how do you improve it? And I hope you're going to use lambda. You're going to end up loving lambda as in your assignments. And this is one of the things that has existed in many other modern languages, and then C++ just have this in the last few years. And so it keeps importing other nice features from other languages. You influence other languages, but then also get influenced by them. And so lambda is one of them. And this, you will notice lambdas in many different, it's also sometimes they call it closures. You may have heard them in the other languages that you're familiar with. There's this, it's just syntax here is a little different perhaps, but you can get used to this. As you see, the declaration is this square bracket has other usages. Remember previously we said, okay, function you can pass by value or by reference. And this is where you can specify this. So here, let's just say we don't bother with this. This is fine. For our programming assignments, exercises, we don't bother with this. Let's just say using the default is a passing by value. If you want to pass by references, actually remember the references that you want to use the address operator. This is what you do. You pass by references. And then the lambda, inside lambda has, in terms of scope, you can access all the variables within the nearest, the outer block, right? In this case, you can access this block, anything is defined here, and also access whatever is in that function block, if it's not hidden by this, by the block. So anyway, we have seen the scope rules, the same thing. You can access those variables outside, and just like a function versus the global variables. And here, this is a formal parameter list, just like a function, and this is the body. So you declare this lambda here, and now I'm using this right away. Think of this as a function f, and now I'm invoking it right away with the arguments. So this takes two parameters, right? X and Y. So I'm invoking it right away with a max and a num. This is just the same way as this here. You see this statement, larger max num. This is the replacement of a larger. This lambda is the same as a larger in terms of functionality. Okay, here we're using lambda. Now I'm writing this quasi function in line. It's a lambda. So if it's a function, I can't really do it. I can't define larger right here, right? It's just not allowed. Some languages it is allowed, like a JavaScript. But but so this is just lambda, just an introduction of lambda. I hope you'll end up using this and just getting used to it. Any question about lambda? Now, this is not everything about lambda. I just want to introduce you to the simplest. This is inside it is like a function. You can do whatever you want. Typically, don't make it too long. If it's a very big body, make it use a function.
Yeah, I have a question.
Yes.
Yeah, can you actually write the lambda into a parameter, or do you have to first define the lambda into
One more time. Can you put this in a? You mean can you pass this as a parameter?
do I need to first put it into a variable to pass the lambda into a parameter, or can I type the lambda directly into the parameter of another function, like a for each, kind of like in JavaScript?
For each. I don't get it.
Oh. That's okay. Don't worry about it.
No, your voice is a little breaking. Your voice is breaking, and for some reason I can't hear very well.
That's okay. Don't worry about it.
Maybe why don't you send me a message on Teams? I'm not able to hear very well. I think you may have a legitimate question, but I don't want to say it's not important. But can you send a message on Teams? And then we'll follow up on that. Okay, I'll give you an answer. Sounds good.
Oh, Professor, you
Okay.
said that we cannot use lambda on a function, right? Inside a function, right?
What do you mean? Cannot use lambda in a function?
Yeah, can we or not?
Yeah, this is in a function. I mean, what do you use it if it's not in a function? Yeah, this is in the main function, as you see, right?
Oh yeah, but I'm talking about like another function, outside the main.
There's no technical difference. Main function is a function. User-defined function is a function.
Oh, okay, I understand. Yeah.
It's
Sorry.
just the rules are the same, be it a main or not. This is just defined by the language that this is the entry point to your program, so that the program knows where to start.
Yeah, true. Thank you.
Yeah, it's still a function. Nothing special about this. Previously, I mentioned about it can take arguments. Now, I think when we talk about the arrays in the next lecture, probably we'll have a lot more. Some of you probably already understand this. So this is a multi-dimensional array, essentially. It's like an array of strings. The char asterisk, that is the the type that can point to a C-style string, a null terminated string, and you have one more indirection. So that gives you 2 dimensions. So that when you run the program, say you run remember that, for example, git status, right? Imagine git is your C++ program. After is executable, you have built it. And then you're going to pass you a bunch of parameters, whatnot, it's a message, let's say, git commit. So, okay, git commit -m, blah, right? This is your program. You're passing a bunch of parameters. All these parameters will be presented here in the argv. And you can access each one of them. And this this argc is telling you how many arguments, 1, 2, 3, separated by spaces. So we don't really necessarily going to teach about argument processing, but just so that you understand, if you want to take arguments, this is what you can do here. Okay. So far, our programs don't take nothing. That's kind of our exercise because this is irrelevant to what we're learning. All right, so I think this is it about the lecture. And if anyone has any more questions, you can stay. Otherwise, you may leave. And we're good here. I'm gonna stop the recording, and then we can talk about whatever question you may have. Okay.